got something I have to save us some time, okay?
Okay.
Because we can...
Look at number 5. Elimination. You had to have the same number with the same letter, right? Catherine? Put that up. Or I'll put the baby plugs in there where y'all won't get to charge them. Let's go. Get your stuff out. Stuff first. That second. Alright, same letter. So, can I get 9 and 5 to be the same?
No.
Or can I get 4 and 8?
4 and 8.
How do I get 4 and 8 to be the same?
Dividing?
No, I want to multiply.
Multiply.
Which one?
The 8.
The 4. What do I need to multiply the 4 by to be 8? 2. There you go. Alright, so what's 2 times negative 5?
8.
Negative 10. You're multiplying. What's 4 times 2?
8.
8. Why? What's negative 17 times 2?
37.
Negative 34. Alright, you see how these two became the same now?
Yes, ma'am.
How do I make 8 and 8 become 0? Do I add them or do I subtract them?
Subtract.
You subtract. Very good. Alright, what is negative 10 subtract 9?
1. Negative 1.
Nope.
Positive.
Nope. Negative 19, Eric. Very good. You got to use your calculator. Remember these? You had to use your calculator. Alright, what's 8 minus 8?
0.
That's 0. What's negative 34 minus negative 15?
49.
Nope. Got to use your calculator. Negative 34 minus negative 15.
26.
Positive or negative?
And plus negative.
Negative.
Negative. Good. I don't know.
Isn't that negative 30? Oh, that's negative 19. Golly. Alright, now what? How can I get... Okay, look. The next person that I see that is turned around or playing with their cell phone or not doing their math work is going to have an issue. Now stop it. We're about to have a seat change for several people. How do I get this negative 19 away from the x? Divide. It would be how much, Catherine? 1. Very good. X equals positive 1. Alright, so let's see. Do you see one that x equals positive 1? Is this positive 1? No. Is this positive 1? Yeah. Is this positive 1? Yes. What about this one? No. Alright, so I got 2 answers, right? Cameron, what you got, Bobby?
I need one of those.
Were you not here Friday? Yeah, you were not. I sent it to you. Did you?
I didn't get it.
Oh, do I have an extra? Yeah, come here. Here you go. All right. So what can I do with x equals 1 to find y? I can plug it back in, right? Which one do you want to plug it into? Roberto.
Top 1.
Top 1. So I'm not going to put the x. I'm going to put what number?
1.
1. All right. What's negative 5 times 1?
I don't know.
You don't know. You have a calculator. You should know negative 5 times 1. Negative 5. All right. Now what? You add 5, Katie. Very good. Jackson, you getting this, dear? You don't have a piece of paper? You don't have a pencil? You don't have a calculator? If you don't, there's plenty of that over there on that table for you. Go grab one.
Blackman?
Yes, ma'am.
Montez Ford.
Montez?
Yeah,
Yes, ma'am.
thank you.
I think her speaker was going out. Ma'am? I do not have an extra copy. I had just enough for all of them.
Here, I'll make some copies. Yeah. Let me have yours, Cameron, before you start writing on it.
All right.
He should have already written something on it. Okay. All right, so what do we have left?
That's far away.
Cameron, come here. We're going to make a seat change right here. Start with you. Bring your stuff. Let's go. Right here.
Right there. All right. Love it.
All right, so what's negative 17 plus 5? Cody? I am teaching math. I'm not sure why you throwing that stuff in the trash can. How much? Negative 12. Thank you, Katie. You divide by how much? 4. That gives you negative 3. All right, which one had the negative 3? D as in dog. There you go. All right, so I want y'all to work on 6 real quick, okay? Do you see the ones that you can get to be the same? You see the X's? Yes? No? You see them? Write it down. And get your X's to be the same, okay? Alright, Jackson. What'd you multiply by? The top one or the bottom one by 3? The bottom one by 3. Very good. Very good.
Can you multiply by negative 3?
You could multiply by negative 3. But remember, I just do positive. That way I don't make a mistake with my signs. But either one is fine. It works. Alright, so let's see. That's 6x equals negative 27. Alright, how do I make negative 3 and positive 3 become 0? How do I make them go away? Add or subtract? You need to add them. Alfredo, if you did a negative 3, then you would subtract. But since I did a positive 3, I need to add. Negative 3 plus 3 is 0. Alright, what's negative 3 plus 6?
9.
Nope.
Oh, it's 3. 9.
3, very good. You have to use your calculator. Negative 3.
Oh, yeah.
Alright, what's 6 plus negative 27? Negative 21. There you go. Then what? By?
3.
Very nice. How much? Careful, careful. Negative. Alright, let's look at 6. Where's my negative 7? Does this have a negative 7?
No.
No? Does this have a negative 7? Does this have a negative 7?
D.
Look, I don't even have to finish the problem. Look, there you go. Are y'all okay? Multiple choice is easy when it's like that. Alright, we're going to do 7 and 8 tomorrow, okay? 7 and 8 we'll do tomorrow. So let's put that up for right now.
What's the problem on number 9?
Number 9. It looks like a 4. 2 a to the 4. B a.
B a to the second.
Yeah, and then to the 4. Just a little something got messed up on that one. Alright, here we go.
What's this?
Last thing of this quarter. Yep, we'll have a test on Friday. Coach, you want one of these? Yeah. Okay, pass one more up, Coach. Here you go, Abel. Pass one up to you. Here, pass one back to you.
Did you get one each? What? Recommend. Are you the only one teaching us for one thing?
All right, here we go. Y'all ready? Yes, ma'am. Jackson, you gotta pass those four, Bubba. Yeah. Roberto, do you have extra ones? No. Alfredo? No. There's one. They're here somewhere. They just passed them the wrong way. He's got all of them that he needs. Jackson.
I get it.
Try it, Coach. All right. Here we go. You ready? All right. So we have growth and we have decay, right? What does growth mean? Does that mean it gets bigger or it gets smaller? It gets bigger, right? Your money in your bank account is going to get bigger. What about decay? It's going to go down, right? All right, here we go. So number one. Anybody want to read it for me?
No.
I'll read it.
You want to read it, Jackson? Go ahead, Jackson.
The city has done some research and found out that their population in 2005 started with 2,000 people and it's grown by 2.5%.
Roberto.
By inflation,
Hold on, Jackson. You got some classmates that are being rude, and I'm not really sure why, because they know better. Go. I mean, we're doing math class. Go ahead, Jackson.
by an equation that would represent how many people live in the town for any year since 2005, given that we spent percent of the nation crossing, how many people we predict would be in the town in 2050.
Okay, so what formula are we going to use? The growth or the decay? Growth. Why? Because what did it say in the formula? It grew, right? Okay, so here we go. Y equals A parentheses 1 plus R to the T power. All right. How many people did we start with? How many people did we start with? 2,000 people right here. So that's going to be our A, 2,000. And then 1 plus, doesn't change. You getting this, Cameron? All right. All right, R is my rate. R is my percent. What's my percent? 2.5, right? But look, hold on a minute. You got to change it to a decimal. I got to move that decimal 2 places to the left.
Why?
Because it's a percent, and I need it to be a decimal. So I have to, basically you have to divide it by 100. All right, so that's 0.025. T is time. How much time? What's the year we started in?
2005.
2005. What year did it end in?
2015.
15. How many years have gone by? 10. Very good. All right, then you grab your calculator. Ready? You just plug that in. All right, 2,000. We got to do parentheses first. Then 1 plus. Uh-huh. Very good. Then you close your parentheses. It's not times 10. How do we do that exponent?
Second.
No. The little arrow, right? Oh, hold on. I got blurry.
I was talking about my calculator.
See the arrow right here?
Yes, ma'am.
Oh, you're talking about your calculator, William?
Yeah.
Hold on. Let's let this focus. Cameron. I need to see a pencil in your hand and you writing this stuff down instead of dancing.
You weren't writing anything down.
We on our calculator. You should be doing the same thing. All right, what number goes up here? What number?
Ma'am?
What number goes up here? 10. How much? 2,560. Very good. So, how many people can they expect in 10 years?
500.
There you go, Alfredo. They're going to have an extra 500 people, right? Yes, ma'am.
Can I use the regular?
Yeah, it's the same thing. Same exact thing. Your screen will look a little different, but it's the same process. All right, so look, do you know you have a town, right? And your town grows. What has to happen when your town grows? You have to have more roads,
More houses.
more houses,
Resources.
more what?
Resources.
Resources like gas and gas stations and food, more water, more food, right? So a town has to know how many people to expect so that they can plan to grow, okay? So that's why this is important. Plus, if you're talking about your money, you could do the same thing with your money, right? You want to make sure the bank didn't cheat you out of money, so you can do this. All right, let's do number 2.
Wait, did you like use the calculator? Thank you. That was that one part.
What?
The calculator was in the way of the.
Oh, I'm sorry, dear.
Oh, okay.
All right, what about number 2? Who wants to read number 2? You got it, Cameron? Well, you can get to number 3, okay? Go ahead, Cameron.
In 1995, there were 450 cell phone subscribers in the small town of Albertsville.
Uh-huh.
The number of subscribers increased by 75% per year after 1995. How many cell phone subscribers were in Albertsville in 2003?
Okay.
Consider a fractional part of it.
I'm sorry, I didn't see that part. I didn't mean to cut you off, Cameron. I'm sorry. All right, increase. Does that mean I'm going to use growth or decay? Growth. There you go. All right. A is how much we started with. 450 cell phones, right? Or cell phone subscribers, should I say.
Then parentheses 1 plus.
Yep.
Then 0.075.
Very good. All right, let me come over here on the side. 75%, right? Where's the decimal if I don't see one? The end. I'm going to move it 2 places. And William is correct. 0.75. Very good. All right, T is time. Let's see. I started in 95. Go to 2003. How many years have passed between 95 and 2003? 8. There you go. All right, so Katie, your screen may look a little different, but it's the same process. You ready? All right, so we're going to type in 450. Abel, you got your calculator, baby? Abel, you got a calculator? Okay. All right, and then 1 plus 0.75. How do I do this number up here?
Huh?
How do I put this number up here? The little arrow. Very good. Woo, that's a lot of people. That's a lot of subscribers, right?
Whoa.
39,000. Doesn't that make sense? Look, think about 95. Most of you were born around 95, right? Has the number around, not in, has the number of cell phones increased like a lot? A lot? What you got, Cameron?
I got a completely different number.
All right, hold 1 second, and let me write this down.
Never mind. I said it. I got the other parentheses.
Are you sure?
Yep.
Okay. Try it again, see if you can get the same answer. Good? Okay, JC? You sure? Positive?
39,503. Yep.
Do you need help? Yes? Okay. All right. Type it in. 450.
1 plus 0.75.
Yes.
That's the number now.
Because look at where the decimal was. The decimal was behind the 2. This one, the decimal's all the way in the back.
So then you're adding the extra numbers and
All right, let's look at number 3. William, you gonna read number 3 for us?
No.
No? Oh, okay. I thought you said you wanted to.
Better child. Rapper. Emergency. Percent of their air every day. The rat originally contained 4,500 cubic inches of air. Writing equations represent the amount of air and estimate the amount of air in the event after 7 days.
Perfect. Very good. Okay, have you ever been in a swimming pool raft and you're laying there and you like fell asleep and you wake up and it's like half out of air? All the air kind of went out of it? No? I have. My raft must be cheap.
I was in a lazy river.
Lazy river ones? Yep. All right, so if it's losing, that's decay. Very good. So that's y equals a1 minus r to the t. Y'all okay? Okay. So how much air did we start with?
4,500.
There you go. Very good. 4,500. All right, what's my percent? R is your percent.
6.6.
6.6, right, Catherine? All right, so let's move that decimal 2 places. It's 2 every single time. So it's 0.066. Close it. T is my time. How much time? How many days?
7.
7 days. Very good. All right, then we're just going to plug it in. Here we go. All right, how do we get that 7 up there? What do we hit to make the 7 go up there?
Arrow.
Arrow right there. Very good. All right, 2,790. Did y'all get that?
Yeah.
Yeah? It deflated a pretty good bit, right? Okay. All right, we got homework.
Yay. Yay.
I know. I think I'm going to mark off one of those problems.
Why?
Because one of them is like number 4 that we're not going to go over. Because we got to get through this stuff.
Mark 10 and 5.
Huh?
There we go.
No, just one problem. All right, grab your textbook.
So right.
I know.
I was doing one by what's that?
All right, mark out 5, guys. Mark out 5. Mark out 5. At 2 and 10, you got 2 whole problems for homework. Yes. When your notes are finished and your homework is finished and all of your extra stuff is put up, then yes. Because you haven't sat there and done half of what we've been doing. Cameron, you working, baby? Okay.
It almost hit somebody going to office.
That's not good.
It's not. It's like, you know
Are you
how,
driving with your mom?
yeah, you know how there's that, how turning all these is really complicated?
Yeah?
Well, I was coming around that light and I was going to do a U-turn, and this Honda just kept like slowly inching out and almost hit me.
Uh-oh. Yeah, done. What is this? 8? Is this 8 guys or 9?
What?
It's 9.
9? There you go. Try it down.
2 and 10.
2 whole problems.